Hello guys, good evening. I hope everyone is doing good today. It's good to be back and to share a knowledgeable content with you all. And before we jump to today's video series, who are we? We are Data Valley, the fastest growing edtech company of 2025. And if you're wondering what do we offer, we offer multiple streams of career development. So, for example, if you have a company and you need a talent pool of people to take over the job, yes, we have trained professionals who can take over the job from day one itself. But if you're wondering, is that all that we provide? No. We also provide you with training support. So, talking about training, we do training in multiple subjects like data engineering, data analytics, data science, cybersecurity, web development, MERN stack developer, full stack developer, uh, whatnot, whatever is topmost in the industry, we teach them all. And it just doesn't end with teaching, it also extends to training as well. So once you enroll to any of the course with our company, you can be assured that you're going to be a pro in that particular technology or a particular role. And your training just doesn't end with just all you learning and then leaving. We also provide you with 100% placement assistance. So once you enroll in here, the end goal is to make sure that you're placed somewhere and you are getting a job in a very good package. All right, so that is all from Data Valley. And myself, I'm Franklin. I've almost got 3+ years of experience as a data engineer, and I'm super excited to bring today's content to you all. Talking about today's content, we are jumping to the 13th video of this particular data engineering interview series. I thank you all for the amazing response we have got till this point, and let's dive deep for today's video. Okay, so what are we covering today? We are covering AWS Glue for today's lesson. If you're wondering, yes, I did teach you AWS Glue in series number 11 and 12. And how is this different? Yes, it is different. In the 11th video, we learned about the fundamentals and basics. And in the 12th video, we learned about the practical application and design. And guess what? We cannot learn the application and design in just an 1 hour video. So I've grouped it into three parts. And let me also give you a disclaimer. Your practical application and design just doesn't end in three videos. But however, I've compressed it and comprised it to three videos. And this will be the second video of your practical application and design of your AWS Glue. So in this video, we are covering the second part of our practical application and design using AWS Glue. All right. So what is our first question for today? Our first question is, explain how to build an end-to-end ETL workflow using multiple jobs in AWS Glue. You might be wondering, this is something similar to the question that we saw in our previous video, but there is a slight difference. So what is the difference? In the previous video, we learned the process of creating an end-to-end pipeline from a start to the end of a complete ETL pipeline, right? And that was all for one job. But here the question is a bit different, and the difference is very understandable in the question. So you are designing an end-to-end ETL workflow using multiple jobs in AWS Glue. All right. So in your previous video, we learned about creating an ETL job for one. And in this one, we are learning about the ETL workflow using multiple jobs. All right. Let's dive deep to know more about designing it. This is just a reference picture. Do not worry about it. Uh, it would make sense, but what I'm trying to say is it is not exactly what I'm trying to teach. Maybe in the end, I'll try to get to what I'm trying to explain here. Okay. First, building an ETL workflow using multiple jobs in AWS Glue primarily involves creating individual glue jobs for specific stages. Example: extraction, transformation, loading, and then orchestrating their execution using AWS Glue workflow. So in our previous video, we learned about creating an AWS Glue job by taking just one ETL job, right? So your ETL job in a whole is going to have all the script necessary to do the extraction, to do the transformation, and to do the loading as well. But in here, what are we trying to do is we are going to have individual glue jobs for specific stages. So for example, for extraction you might have a separate job. For transformation you might have a separate job, and for loading you might have a separate job. Okay, and the key thing here is how are you going to connect them all together, and then you're going to orchestrate this workflow. And one thing, if you notice here, the job is getting distributed. So it is not just one job in like full package, but rather it is a variety of stages differentiated into different jobs. All right. Okay. Now, if I have to design an ETL workflow, the primary tool that I must use is AWS Glue workflow. So AWS Glue, and then you have AWS Glue workflow. In AWS Glue, you define just a job. So you can create as much jobs as possible in your AWS Glue. That's fine. So where does this AWS Glue workflow fit in? This AWS Glue workflow is also called as an orchestrating tool. So how is this going to orchestrate is that it can connect multiple jobs together along with its dependency and create an workflow which is going to run sequentially in an execution order. Okay, so that is the key difference between AWS Glue and your AWS Glue workflow. So for your ETL workflow, first thing what you have to do is you have to define your ETL stages and create individual AWS Glue jobs. And within that, the very first step is to create your extraction job. Okay, create AWS Glue jobs either using Python shell or Apache Spark to extract data from the source systems. So your source system can be anything like AWS S3 Data Lake, an Amazon RDS, it can be Amazon Redshift, it can be a NoSQL database, it can be a JDBC compliant database, it can be another warehouse, it can be another file system, whatever not. So you can have variety of data sources, and in this extraction job phase, what you're going to do is you're going to create this AWS Glue job to extract data from all these kind of data sources. And these jobs might simply read data and land it in a staging area. So what is this staging area? This staging area is the place where you're going to stage all the files from a different source system. What again? Okay, let me explain in a real world scenario. Let's say I own a company called Apple. Okay, you all know that Apple sells phones, laptops, headphones, whatever, they sell a lot of things. But let's keep it simple. Apple company is having phones within them. But there is also an option for you to purchase Apple products from third party vendors like Amazon, eBay, Flipkart. So you are also able to purchase these Apple products from another website as well, which can be still hosted by Apple itself. So without a distributor, they themselves can be a distributor, but still they sell their product in different e-commerce websites, right? So when I'm trying to get the data in my staging layer, I'm going to have the data coming from different sources. So, talking in this context, one from my website. So, if you're making a purchase from my website, I'm going to have all the details of it. So, one kind of file system is in my native database, and the other one is going to be sent to your third party vendor. So, your third party vendor will have all your information about who you are, what is your profile ID, what is your contact address, and what is the product that you have purchased. So, their information is going to be stored in a different database. But I need all the information so that I would understand that what is the purchase happening with my particular product. I want to do inventory management, so I need to know how many products have been sold, and I would like to know which platform is selling the most product. Is it my native Apple website, or is it some other third party website? So in this place I need to collect all these data to get a proper insight. So what I do is I get all my data from different sources, and then I put them into my staging area. For example, talking in AWS context, it is S3 data lake. And then the transformation jobs. We developed separate AWS Glue jobs to perform data transformations. This could include data cleaning, enrichment, aggregation, joining multiple data sets, applying business logic. So it depends, whatever your business use case is and whatever your data requirement it is, you try to clean it. So cleaning in the sense, you try to remove unwanted values or unwanted data from your particular data set. Enrichment in the sense, for example, in different countries they might read the data in different format. For example, like in America they used to have month, year, and year. But for example, let's say if you're from India, you read the data you read the date in format as date, month, and year. So you need to enrich it in a way that it is understandable to your local geolocation. So that is a kind of an enrichment. You change the format of your data. And then you have aggregation, then you have joining multiple data sets. So as I said earlier, your data, multiple data files fall into your staging area. Now you have to join all these and create a unified file, right? By applying all your business logics and whatever the requirement is from your analyst team or your machine learning team, your data science team, whatever the downstream team is. So you design your transform job in that way. And then you have your loading jobs. So what do you do to your transformed data? So create AWS Glue jobs to load the transformed data into your target data warehouse or data lake. Example, Amazon Redshift, Amazon S3 for data lake. So whatever the transformations that you have done in your data, now you need a place to load them all. So it's a target destination, and you need to define it so that whenever your transformation job is complete, your data gets loaded up somewhere. And the target destination can be a data warehouse, or it can be a data lake, or it can be another database itself. It depends, and not just to only to your AWS ecosystem, but also you can load your data to data warehouse like other data third party data warehouses like Snowflake, Databricks, Teradata. You have multiple data warehouses, and even to other clouds you can load your files. So first you have to define your ETL stages, and then make sure that you create individual glue jobs for each of your process. All right. Now create and configure AWS Glue workflows. Yes, fine. You have created all the individual glue jobs, and now you're going to configure your AWS Glue workflow. Why is that? Because AWS Glue workflow is the one that is going to orchestrate all your jobs, right? So now it is your part to create and then configure your Glue workflow. First, you have to initiate the workflow. So how do you initiate the workflow? So when you go through your AWS Glue console, you can try to find an option called as workflows. And when you click these workflows, there will be an option that says add workflow. And when you try to click the add workflow, it asks for a descriptive name. Okay, so for example, a descriptive name can be something like, mm, let's say, what is my source? Let's say it's an Oracle database. So Oracle underscore, what is my company name? For example, I worked for a company called Axfood. So it's a Swedish brand. So I put Oracle Axfood underscore again, and then I put my target destination. For example, let's say I'm using Snowflake. So Oracle underscore Axfood underscore Snowflake underscore, and then you can add some description as well, or your date, or who created it, or you can put your IDs, or you can just mention it as Glue workflow. So it all depends on your business format that you have. So once you provide a descriptive name, now you are into the workflow. And within the workflow, you have what you have to do is you have to add triggers. Triggers come into two ways, okay? One is a start trigger, another one is the conditional trigger. So under the start trigger, you have multiple triggers in place. Okay. So triggers, you have to set two triggers. One is your initiating trigger and then is your conditional trigger. I'll explain it to you now. So in the start trigger, you define the initial trigger for your workflow. This can be a scheduled trigger, example, hourly, daily, an event driven trigger, example, S3 event for your new data arrival, or a manual trigger. So, in this initial trigger, what's going to happen is only if this trigger happens, your workflow will start to work. Only if this particular trigger is initiated, your workflow will start to function up. So, this initial trigger can be set in three different ways. One is the scheduled trigger. I hope you all are aware about the scheduled trigger. So, you set a time, right? Or you set whatever the exact time of the day, or exact day of the week, or exact day of the month. So however that you prefer, all you do is you set a particular time, and then your schedule runs periodically. Okay, and then you have event driven trigger. So event driven trigger is quite different in a way that, for example, the most common use case would be whenever a data file falls into your data lake, start processing, start your glue job, or start your crawler. So that is an event driven trigger. So the event here is the data file coming to your S3, which is an data lake, right? It's a storage service from your AWS ecosystem. Or the third method is manual trigger. So manual trigger, in other words, is on demand, okay, or in demand. It's up to your choice to call it that way. So in demand, it's not an automated way. It's an manually. I mean, I wouldn't prefer that, or even in professional network place, people wouldn't prefer setting any on-demand triggers, because we want to automate the pipeline as much as possible. So they need to function independently without any human intervention. So manual trigger is good only for testing or debugging, but if you're talking about the actual work, professional product, I mean, sorry, production environment, do not go for manual trigger. So first is your initiating trigger. So it can be one of these three. And then you have conditional trigger. What is a condition? Eat when you're hungry. Drink water when you're thirsty. Walk when you feel tired. Meditate when you're confused. So all the four statements that I gave, those are conditions. Right? For example, write when you learn. So whenever you are learning, I'm asking you to write, right? So these are different kinds of conditions I can provide you. And talking in context to your conditional triggers, so what happens is that for subsequent joins in the workflow, add conditional triggers that depend on the successful completion of preceding jobs or crawlers. You can use all or any conditions to define dependency. So This conditional triggers come into play that in a way that for all your subsequent jobs in a workflow. So you're going to have a workflow, and for your workflow, you'll define multiple jobs. So it runs subsequentially. Okay, so that's what I mean by for subsequent jobs in the workflow. Add conditional triggers that depend on the successful completion of preceding jobs or crawlers. So the condition I'm sitting here is only when the previous job is successful, I want you to initiate this job. Only when the preceding process or status is successful, I want you to run this particular crawler. So that is your conditional trigger. And there are two conditions you can set within conditions. Either it is all or any condition to define your dependency. Okay, now you're still in the configuration phase, and there is a way that you can also use crawlers in it. But adding crawlers is optional. But if you ask me, it is a recommended way. Why is that recommended and still is optional? For example, what if your data is dynamic? What if your data is evolving? Not just the data, your schema is evolving. So you all know about schema evolution, isn't it? So for example, today you might have a file that has like 5 columns, and tomorrow you might have another file that might have like 10 columns. So that is a schema evolution in place. So how are you planning to handle it? Right? So you need to have steps in place by which you'll be able to handle all these kind of scenarios. So to handle your dynamics environment or ever evolving schema, you need to set up crawlers as well, not just your jobs, but also you need to add the crawlers. So when you integrate AWS Glue crawlers into your workflow, you can ensure that your schema discovery is happening properly, and even your dynamic data evolution is handled well. And what these crawlers do, these crawlers automatically discover schema. They populate the AWS Glue data catalog. So AWS Glue data catalog is your repository management, right? So for all your data, it is going to have your schema information. So whenever this crawler runs, it is going to generate metadata, and this metadata gets populated into your AWS Glue data catalog. So when you try to run your crawler, and then when you load the metadata to your AWS Glue data catalog, your Glue jobs can further try to leverage these metadata from your Glue data catalog. All right, and whenever possible, try to place crawlers before the relevant ETL jobs. Okay, therefore you're making sure that your data is, you're ensuring data integrity. You're also ensuring that all your schema evolution is well handled, because that might even break your, that might even break your job, that might cause a failure, that might throw out an error for your job. You don't want to risk it, right? So always have these kind of options in place so that your ETL pipeline runs properly. Then add jobs. Add the individual AWS Glue jobs you created in step 1 to the workflow. So initially we created multiple jobs, like extraction job, a transformation job, a loading job, right? Now what you do is you add all the individual AWS Glue jobs into a workflow. Okay, and you also have to ensure that you are arranging them in the correct execution order based on our ETL stage and dependency. So depending on what ETL, what kind of execution order we want, we set our jobs in place. And once you do that, you have to do is you have to connect the nodes. So you can visually connect all your jobs, you can connect your triggers, you can connect your crawlers within your workflow to define your execution flow and dependencies. All right. So first you're creating all your individual glue jobs, And then within your AWS Glue workflow, you are defining all your triggers, you are defining your initial and conditional trigger, you're setting your crawler, you're adding your jobs, and now you are connecting them. So you're mapping them in an execution order. Monitor and manage the workflow. So the third step within this is monitoring your workflow. So how do you monitor and how do you manage it? First, monitor the status of your workflow runs in the AWS Glue console. You can view the status of individual jobs and crawlers within a workflow run. So when you go into your AWS Glue console, you will be able to get an understanding of your workflow run. So when you look into your workflow run, you will have all the status, if it is successful, if it has failed, if it has thrown out error, or whatever the problem is. So you can view the status of what's happening with individual jobs or your crawler within a workflow. Then you have logs. Review the logs of individual glue jobs to troubleshoot any errors or issues during execution. So within your glue job, you have two things. Okay, you have your glue, you have your CloudWatch logs, and then you also have something called as error logs. Okay, by using this, you can try to get an understanding of what's wrong. So if you click into error logs, it is going to give you all the error report, and it's going to backtrack somewhere like there is problem here. And what you can do is, based on the information that is provided in your error log, you can try to navigate to the particular script or wherever the problem that is. You can try to troubleshoot them and diagnose the issue. All right. So logs can be very useful in that purpose. Then, setting alarms and notifications. Configure Amazon CloudWatch alarms and notifications to be alerted of workflow failures or other important events. This is very important. Okay. And for alerting, you use SNS, which is called as Simple Notification Service from AWS. But we are not going to dive deep into it. But generally, just know that to send notifications, you need a service called as AWS SNS. So what you do is, let's talk practically. Okay, you have a job running. How are you going to know if the job was successful on that particular day? Okay, if you are the developer, you have the privilege and you have a chance to navigate to your console and have a look. Okay, let's talk about the business stakeholders. Let's talk about your team members. What if they don't have the privilege, but still they would like to know what's the process? So that is where your SNS comes into play. So you create topics, and to these topics, the consumer have to subscribe. And whenever the scenario occurs, okay, depending on the conditions that you have set or what kind of notifications you want to send, whoever has subscribed to these topics, they'll be notified about it. Okay, so if it is successful, if it is failed, at least if if it comes to fail, you can try to fix it, right? So that's why you need to configure alarms and notifications. So by following all these steps, we can build a robust and automated end-to-end ETL workflow using multiple jobs in AWS Glue, enabling efficient and scalable data processing. I hope this is very clear. So this is how you create multiple jobs, and then you use AWS workflow to Glue workflow to orchestrate your pipeline. All right. Next, how do you implement data quality checks within an AWS Glue job? We learned about constructing an end-to-end ETL pipeline. We learned about constructing an end-to-end pipeline with multiple jobs. Fine. So you're processing the data. How am I going to ensure data quality for all these jobs? That is your next question. And implementing data quality checks is must, because you need to see, as a data engineer, it is your duty to provide a quality data so that you get a right output, right? For example, a data analyst, they want to get a report. For a data scientist, they need to do predictions. For machine learning engineer, they need to train their models. So for all these scenarios, the data engineer has to provide the data in utmost qualified format. Okay, or in other words, he has to provide the data with all its integrity and data completeness. Okay, implementing data quality checks within an AWS Glue job can be achieved using AWS Glue data quality, which allows to define and evaluate rules against the data. So within AWS Glue, you have a service called as AWS Glue data quality. Okay, so using this, you can define and try to evaluate against your data. Now, the first process of using your AWS Glue data quality is you have to define data quality rules. So, what are the rules? So, I can have multiple rules in place. For example, I want I don't want to have any null in place. That is the rule, isn't it? And I don't want to have, let's say, I don't want to have any alphabets in place of the integer column. So, for example, a column must have only integer format. By some chance, let's say I've got an string. I don't want it. So, I want only the particular uh, column to have only particular data type. For example, a name. So, within a name, I don't want to have any numbers. All I want is only the characters or alphabets. So, I can keep a data quality check there. So, what you do is you have all these kind of rules, and from your rules you create something called as rule set. Okay, so rule set is nothing but a combination of rules. Define data quality rules within a rule set using the AWS Glue data quality definition language DQDL. These rules can check for various quality aspects like completeness. So when you define your rule sets using DQDL, okay, there is a definition language used by data quality of your AWS Glue. So you when you set rules with DQDL, you can check for various quality aspects. For example, data completeness. So for example, a particular column, you don't want to have any null values. So you ensure that if the data is complete. Uniqueness. For example, there might be a column for an ID, and you want the ID to be unique, right? It shouldn't be overlapping. It shouldn't be duplicated. So you want all your column, a particular column, to be unique. So you can set that as a rule. Then the data validity. So for a particular column, you can set so like a value between 0 to 100. For example, marks in the exam, it cannot be below 0 or above 100, right? So you can set a particular validation there. Or for example, you might have a column and you are setting an regular expression like percentage at percentage dot percentage, which is nothing but an mail ID. So first percentage is going to carry some name, and you will be having at. So after at, you'll be having options like Outlook, Gmail, Hotmail, Yahoo. You have multiple options. So percentage dot percentage. So you are doing validity check there. You can ensure consistency. So rules comparing values across columns or against reference data. So you check for consistency by comparing the data from the current column and to your referenced data. The rule creation. So we can create these rule sets directly in the AWS Glue console or programmatically within the Glue job script. So either using AWS Glue console, or if you prefer writing it programmatically, yes, you can create the rule sets using your Glue job script as well. AWS Glue can also recommend rules based on data profiling. Then integrate with your Glue job. So first phase, what did you do? You defined your rules, right? You defined your rules, therefore you created your rule sets, and we learned on what basis do you set rules. So there are two options. You can set your glue rules based on your AWS Glue console or programmatically using the Glue job script. Now, integration with your AWS Glue job. You have created it, now you have to integrate it. Therefore, your data quality check is going to be performed. First, in AWS Glue Studio, add an evaluate data quality transform to your visual ETL job. This transform allows to apply a defined rule set to the data. So what you do is, in your Glue Studio, which is nothing but an visual interface, right, to create your ETL job. So within this visual interface, you will have different kind of options, okay, the transforming options. So of which one is called as evaluate data quality. So when you click this and you map it to your ETL job, this can check for your defined rule set to the data. So whatever the data, the rule sets that you have set, it allows you to apply the rule sets to the data. Okay. Of next you have programmatic integration. In a Python shell or Spark ETL job scripts, you can import the data quality module and use its API to evaluate rules against your dynamic frame or data frame. So either in your Python shell, okay, which you do it locally, or in your Spark ETL job script, what you do is you import the data quality module, like how we import multiple, modules like pandas. We import multiple modules, right? Similarly, you can import data quality module, and then you can use its API to evaluate rules against our dynamic frame or our data frame. Let's see a sample code here. So in here, as you can see, I've got multiple modules downloaded, right? From AWS Glue data quality, I'm importing multiple functions: data quality rule, data quality rule set. So I can download all those from the particular module, and then I'm using here AWS Glue dynamic frames. Okay. Now, at first, what I'm doing, I'm defining the data quality rules. So from your rules, you create your rule set, right? So rule sets are nothing but a combination or a multiple rules together combined. So rules. If you see here, I'm calling the first one, right? I'm calling a function called as data quality rule, and within that, I'm selecting the column age, and I'm giving a condition there. I want the age to be greater or equal to 0, and age lesser or equal to 120. So a age cannot be less than 0, right? And your age cannot be obviously above 120, because that is like an once and rare thing, and I don't think that has ever happened as well. So that is one kind of a condition. And then what is the name of this rule? It's called valid age range. And then you're defining another rule, data quality rule, and within that you're selecting the particular column called as email. Okay. And then you have your expression, email like percentage at percentage dot percentage. So what does it mean? So the percentage here means the alphabets. So you want the email to be in this particular format. So how does the email look like? For example, franklin.florence at outlook.com. So that is my mail ID. So here I'm defining that I want an at the rate, and after that I want some text, and then I want something like .com, or it can be anything. So I'm defining a rule there how my email should look like, and I'm giving a name called as valid email format. And now I'm creating rule set from all the rules mentioned above. So rule set is equal to data quality rule set, and within that I'm giving a name called as my rule set. And what are the rules in it? So I'm saying this rules combine to form my rule set. And further, if you see that, then I'm evaluating the data quality by using evaluate function here. So I'm comparing it to my, you know, I'm checking it against my dynamic frames with the whatever rule sets I've got. So in the evaluation phase, what happens? Your data against, so this is my data frame, right? My dynamic frame. What is the frame I want to compare again? So to my dynamic frames or data frames, I'm applying this rule set to have a check. So when you do that, now what you can do is you can filter out your bad data as well. Okay, so data quality results dot get data quality status. So by that you will get the status of all your data, whatever is successful, whatever has failed. By using different key terms of your status, you can try to filter out and then process them separately as well. Okay, next, action on data quality results. So first you define the rules using your rule sets. Then you incorporated that your ETL job using data quality module, programmatically speaking. For visual interface, you can use AWS Glue Studio. Now what? I've checked, I've ran everything, I've done the function. I've run the job. Now what? Now what you do is you filter out the invalid records. Use the results of the data quality evaluation filter. So this is your data get data quality status, right? So you use data quality evaluation. You get the results of your data quality evaluation to filter out records that fail specific rules, preventing bad data from propagating downstream. So whatever the bad data that you have, you don't want to process it. So you're stopping it straight away. Generate reports. The data quality evaluation provides metrics and details on rule failures, which can be used to generate reports for monitoring and analysis. So once you filter out your valid and invalid records, now you can, depending on the status and with the proper metrics and wherever the rule set have been breached or failure to the particular data, you can segregate them and you can create reports as well, which can be used for further monitoring and analysis. Then it just doesn't end there. You also have to integrate with other AWS services like Amazon SNS, which is nothing but simple notification service, or CloudWatch to trigger alerts when data quality falls below acceptable thresholds. So what you're doing here, so you are integrating your particular data quality with SNS and CloudWatch, so that you get the notification and alerted about whatever the data quality failures that has occurred. Okay, so you define threshold, and whenever the particular threshold is closer, you get an alarm, okay, or an alert. In critical situations, configure the job to stop the pipeline if data quality issues are severe, preventing corrupted data from impacting downstream system. For example, if it goes beyond the threshold, if it crosses against whatever the preferred threshold is, then what you have to do is you have to make sure that your pipeline is stopped. Why is that? Because you don't want to impact your downstream systems as well, right? So make sure that under critical situations you stop it from working. Okay. Okay, next, how can you schedule and automate AWS Glue jobs using triggers? So you all know about scheduling, right? You all have been hearing them eventually many times, I must say. Now, how can you schedule and automate your Glue jobs using triggers? So that is what we are going to see now. It's very interesting thing. So please stay focused. This will, it's like added bonus you can explain in your interview as well. AWS Glue triggers or mechanisms used to initiate AWS Glue jobs or crawlers automatically, enabling the scheduling and automation of ETL processes. So your Glue triggers or a component or a mechanism under your AWS Glue service. Okay, and these can be enabled to initiate a job or a crawler to run by its own. Okay, and even you can set triggers that would enable to schedule and automate your ETL pipelines as well. So triggers play an crucial role in the process of automation. So before we understand how to automate, let's learn about the types of triggers in place. Scheduled triggers. So the scheduled triggers, as the name suggests, it runs in a periodic fashion. It runs for a particular scheduled time period. So as by the definition, these triggers initiate a job or crawler at a specified time or recurring schedule using cron expressions. So you will provide cron expressions and then your triggers run periodically to schedule your job. The configuration. You define a cron expression to determine the frequency. Example, daily at a specific time, every Monday, whatever. So in the configuration phase, what you do is you define a particular cron expression. So cron expressions are nothing but which particular day would you want to run, which particular day of the week would you like to initiate the progress, which particular week do you want to initiate this particular job. So you design your scheduled trigger based on a cron expression. Talking about the use case, ideal for routine time-based data processing tasks such as daily data aggregation or weekly report generation. So whenever you want to perform a routine based job or a periodic job, okay, or whenever you want to perform a time based data processing task, then you can go for using scheduled triggers. Of next you have conditional triggers. Conditional triggers. These triggers initiate a job or crawler based on the success, failure, or stop of one or more preceding jobs or crawlers. So you all know what is a conditional trigger, right? I've just explained it before. So depending on a condition, if something is true, do it. If something is false, don't do it. So similarly, instead of just giving, Boolean values, we are providing conditional statements like success, failure, or a stop, depending on the preceding job and crawler. The configuration is you specify the job or crawler to watch and the desired state. Example, start after all watched jobs succeed. So in this, what happens is your condition is how would you like to initiate your job? What is the condition of your preceding job? Is it successful? Has it failed? Or what is the condition there? So you specify the job or crawler to watch and the desired state. So depending on the state of it, you initiate your trigger. Essential for building complex ETL pipelines, where tasks depend on the completion status of previous steps, ensuring data integrity and workflow. So already in the AWS Glue workflow, we learned about the conditional triggers, right? So we learned two triggers there, the initiating triggers and conditional triggers. So conditional triggers are key for your ETL job. Therefore, what you do is whenever you want to have a conditional trigger, it will ensure that your previous or preceding job, the status is true. So because it is a sequential process, isn't it? So depending if a condition is true, you would initiate next job. So what if your previous job has failed? I don't want to initiate the next one. It's simple as that. So whenever you have a complex ETL pipeline, and you have to ensure that the condition of a particular previous job is successful. Therefore, this trigger gets initiated and your job gets performed. And this is highly useful when you want to ensure high data integrity and flow control. Of next, you have on-demand triggers. So, the purpose of using on-demand triggers is they can be initiated manually, and they provide us flexibility for ad hoc job executions. So on-demand triggers, in other words, you can call it as manual trigger as well. It is just like you go and you say run. It's just like that. You click it on demand. Okay, no periodic scheduling, no event based. So you manually run the job for your on-demand trigger. And what is the configuration? You explicitly start the trigger when needed. So whenever you want the trigger to start, you explicitly start your trigger. All right. Use case: useful for testing, debugging, or running a job outside of its regular schedule for specific purposes. So whenever you want to have a testing, why did I say testing? Let's say you're running a job, it has failed, okay, for some reason. Let's say your source wasn't defined. Now, based on the error logs, you will get to have an idea about what happened, and now you will try to solve it, right? Now, when you solve it, you want the job to be running immediately, or do you want to wait for the next day because you have set something like an periodic trigger? No, isn't it? So, whenever you have a particular requirement like testing for a debugging, or outside of the regular interval you want to run your job and check if it is successful or if it is able to function, yes, go for manual triggers. Then you have event based triggers. So event based triggers, the purpose is these triggers are typically integrated with other AWS services like Amazon S3 or Amazon Event Bridge to initiate jobs based on specific events. So what do you do in your event based triggers? These triggers, like, what happens is that it is interrelated with other services. Why it is interrelated? Because event based triggers are based on the notifications, or it depends on the particular events. What do I mean by events? So event includes, like, whenever a file is uploaded to my S3 bucket, I want you to start the ETL job. That is an event, right? So whenever this is the most common scenario. That's why I just mentioned whenever a new file is uploaded to the S3 bucket. So whenever a file gets dumped, I want you to start the extraction job. So that is an event-based ETL job, right? And what is the configuration? Use Serapen's event source example, S3 event notification that invokes the glue trigger or lambda function that then starts the glue job. So you configure a source and you define a glue trigger, or you can even set a lambda function which will initiate your glue job, okay, depending on the notification or the event. The use case: it enables real-time or near real-time data processing as data becomes available in the source system. So this is like a real-time processing, right? Whenever the data gets dumped into your S3, you just process it straight away by initiating your glue job automatically. So this is an event-based trigger. Now here is our key part: how to schedule and automate AWS Glue jobs using triggers. First, all you have to do is you have to create a glue job or a crawler. So you will be developing an ETL script for your ETL job, right? For your glue job, you are developing an ETL script. Or you can configure your glue crawler to discover the metadata. So what are you doing? Either a crawler to discover your metadata, or a glue job that has the ETL script in it. Fine. Now, this is where you define your triggers. How do you define it? Go to your glue console Under the Glue console, you will find an option called as triggers. And when you select triggers, there you have an option called add trigger. Select the desired trigger type like scheduled, conditional, on demand, or event. So you select a trigger based on your desired type. So we just discussed, isn't it? Scheduled, conditional, on demand, or manual, or event based. So you select the type of your trigger, and then you configure the trigger properties correspondingly to the type of triggers that you have chosen. For example, for a scheduled job, you go for a cron expression. For example, for an event, you specify the event source and event notification service. So corresponding to your job, you define it. Then, so you have created your glue job or a crawler. Let's keep it simple. You have created a glue job. Now you have defined the trigger for it, and now you associate the actions. So you specify the glue jobs or a crawlers that trigger should initiate when it fires. You can also pass arguments to the job or crawler if needed. So whenever the trigger is initiated, okay, so you specify what job needs starting, what crawler needs running. So depending on your glue job triggers, whenever it fires, you want to initiate your glue job or crawler. So you associate them. Okay, and now you activate it. So after creation, because you have associated it already, right? You created a job, you created triggers, and now you have associated the actions. Job to the trigger, you have associated them, you have joined them. Now to activate, after creation, activate the trigger to enable it to monitor its conditions and initiate the associated actions. So whatever the trigger type that you have provided, for example, if it's event based, try to upload a file to a S3 data lake. If it is a schedule, like set it to run for like every 1 minute or 5 minutes. So periodically it will be running and you will be able to test it as well. So whatever, or if it is on demand, you just press it and your job starts running. So you try to activate your trigger and then check if the associated actions are happening eventually. So by leveraging these trigger types, you can build robust and automated data pipelines within AWS Glue, ensuring efficiency and timely data processing. So I hope this session was very useful to you, and I believe we learned really a lot of stuff today. And if you have any questions, feel free to drop it in the comment section. And if you find this video useful, like the video so that I'll be motivated to, show up with a lot of contents. And before we end, who are we? We are Data Valley, the fastest growing edtech company of 2025. And if you are wondering what do we provide IT solutions, training support, and 100% placement assistance. So if you have any questions to us on how we can help your career, feel free to reach to our website at datavalley.ai, where you will have quite a lot of details about reaching to us and your pathway to success, how we can get a tailored roadmap for your development, everything. And before we end, thank you all for joining to this video, and I'm looking forward to see you in another session as well. And we have our headquarters in US, UK, and 4 data centers in Hyderabad. And soon we are expanding to different data centers across India like Chennai, Bangalore, West Bengal, Delhi. So if you're someone nearby, do give your support and we will get to you as soon as possible. So talking about trainings, we provide training in multiple streams of subjects like data engineering, data analytics, data science, machine learning. So multiple subjects. And one more good thing is that we also teach our subjects in multiple languages like Tamil, Telugu, and English. So if you are of any of the regional speaker of these languages, feel free to check those channels as well. So it is Data Valley Tamil and Data Valley Telugu. If you just type in, you will be able to find, and don't miss out on these valuable resources. I wish you all good luck to learn as much as possible and ace your next interview. So that is all for from me today. We'll see you in another video. Until then, this is Franklin signing off. Bye bye. Take care.